Hi everyone, this video is really just an answer key for the 2.5 and 2.6 formative quiz that we gave in class. So if you struggled with any portion of the quiz, you should watch this video to help you walk through these problems so that you can be ready for your Module 2 assessment coming up next week. So questions 1 and 2, the directions are determine whether the following equations are equivalent. Show your work to support your answer. So just as a reminder, equivalent just means, are they the same? Are they equal to each other? So we need to take a look at these equations and decide if they're actually equivalent. The way that we're going to do that is we're going to do two different things. The first thing we're going to do is distribute, which really means we're going to take a number and multiply it inside so that we can get rid of parentheses. The second thing that we're going to do is combine like terms. If you need help on this particular concept, it's actually in the 2.5 Ready, Set, Go video notes. So you can rewatch that video to get a little bit of extra help on this also. But let's take a look at these two examples. So in the first one, we are given y equals negative 6x plus 3. So that's my first equation. And my second equation is y equals negative 6 times x minus 1 minus 3. So I'm going to rewrite that one down here because this is the equation that I can actually simplify. There's some stuff going on here that I can take care of. I see this negative 6 being multiplied in front. So I'm going to take that and distribute it inside the parentheses. When I distribute, I know that I'm multiplying. So that means I'm going to have y equals negative 6 times x is just negative 6x. Negative 6 times negative 1 is a positive 6. So I've taken this number out front and multiplied it inside the parentheses, which made the parentheses go away. And then this negative 3, I didn't do anything to it, so I'm just going to drop it down. I'm going to bring it along. Now I can look at this and I see that there are some like terms. I have a positive 6 and a negative 3 that are both just numbers. Since they don't have a variable, they're both just constants, those are like terms that I can put together. So 6 minus 3 is just a positive 3. So that means I can simplify this down to y equals negative 6x plus 3. So that second equation simplifies all the way down to this. If I look at my two equations then, I can see that those are the same, which means that yes, these equations are equivalent. We're going to do the same thing in number 2. So in number 2, here's my first equation, y equals 1/2 x minus 7. My second equation is y equals 1/2 x plus 10 plus 4. So now the number that's being multiplied in front is this 1/2. I'm going to distribute it inside, which means multiply. So I get y equals 1/2 times x is just 1/2 x. Then I have to do 1/2 times 10. So if I use my calculator to do 1/2 times 10, I would get positive 5. And then the plus 4, I didn't do anything with. It's not inside the parentheses, so it's just going to drop down. And then I can see that I have some like terms right here. Those are both just numbers, so I can put them together. So y equals 1/2 x, and then I can do 5 plus 4, which is 9. So this is my simplified equation. If I take a look at the two given equations then, this one was 1/2 x minus 7, and this one simplified down to 1/2 x plus 9. Those are not the same, which means these two are not equivalent. Again, if you need some help with that, that was in the 2.5 video. So there's another example in that video if you need some help. Okay, let's take a look down here. So we're going to be writing equations of lines for these three questions. So in question 3, it says write the equation of the line going through the point 3, 6 with a slope of negative 4. So if it's going through this point, that means I could make myself a little mini table, going through the point 3, 6. So that's my x value, that's my y value. And it says it has a slope of -4. Well, I know that slope is a pattern, and that when we write the equation, slope, we use m, so m is -4. Well, I have everything I need in order to write my equation because I need a point, a starting point, and I need a slope. So I'm going to go with y of x equals my starting y value, which is 6, and then I need my pattern, which in this case is -4. And then I know that inside the parentheses it always deals with my x, and I need to figure out what my starting x value was. So since my starting x value was +3, I'm going to make this a -3 because we need to be able to back it up to 0. So my equation is 6 minus 4 times x minus 3. And then we can rewrite it into point slope form so that it's -4 times x minus 3. And we're taking that +6 and we're just going to put it at the end. So it's +6 at the end. Either one of these answers is acceptable though. These both tell us the same thing. We had our starting y value, we've got our pattern, and then this x minus 3 tells us our table started at +3. All right, for question 4, we're given these 2 points. Write the equation of the line going through the point -2, 7 and the point 4, 5. Well, we know in order to write the equation, we need a slope and we need a starting value. So right now we don't have the slope, we need it. But if we're given 2 points, we can make a table. So we have the point -2, 7 and the point 4, 5. In order to find slope from a table then, we have to think about what that means. That means we need the change in y over the change in x. So the change in y just means what's the pattern with the y's. So to go from 7 to 5, we're going to subtract 2. That means then that my change in y is a -2. Then I need my change in x, which really just means what's going on with the x's. Well, to go from -2 to +4, we're going to have to add 6. So my change in y is a +6. If I use my calculator to simplify this, remember you can do alpha y equals to put in a fraction. And once you put this in, if you just hit enter, it'll give you the simplified version, which would be -1/3. So now I have my slope and I have my starting point. So this equation is going to be y of x equals my starting y value, which is 7, and then my pattern, which is -1/3, and it's going to be x plus 2. Since my table started with an x value of -2, my parentheses are going to be x plus 2. Now if we want, we could put the 7 at the end, so it's going to be -1/3 times x plus 2, and then the plus 7 can go at the end. Now if you wanted to use the other point, you could. So I'm going to just go ahead and just do 5 minus 1/3, and then it would be x minus 4. So if you had that as an answer, that would be acceptable also. And you could, of course, put the 5 at the end instead. Doesn't matter which point you use. I always just use whichever one is first in my table. So that's why this would be my answer. Okay, for question 5, write the equation of the line shown. Well, this time we're given a graph, and we know that we need a slope and a starting point. So I'm going to look at my graph, and I'm going to see if I can find my slope. So I see that there's a really nice point right there. So I'm going to go over to the side and make myself a table. So that point right there was the point 0, 3. And I can see that there's a point right here at 1, 1. Now I have 2 options for finding my slope. I could do the change in y over the change in x from my table, just like I did in question 4, or I could do the rise over the run from my graph. So I'm going to do rise over run. which means I just need to count. So to go from this point to this one, I'm going to need to go down 2, so that's a negative 2. And I'm going to need to go over, oops, negative 2. It stops here. Sorry about that. And then I'm going to need to go over 1, so that's a positive 1, which means my slope is going to be a negative 2. And I'm going to use a starting point of 0, 3. Since my table starts at 0, I can use slope-intercept form. So I'm going to do f of x, or you could do y of x, since I chose y, sorry. Y of x equals negative 2x plus 3. You could also, if you want, write it as y equals 3 minus 2x. Either one of these answers would be acceptable. Okay, let's move on. So now we're given the equations and we need to be able to make a graph. So taking a look at number 6, we can see that this is a line in point slope form, which means the two things that we're given are a point and a slope. So that's what's actually going to help us make our graph then. We need to be able to look at this equation and decide what's going on. So if I wanted to make a table, since this is x minus 5, that's telling me my table must have started at a positive 5 for my x, because I need the opposite. And then this y value that's by itself here is 3. What that tells me is that my starting point must be 5, 3. So I know my line is going to start there. And then my slope, which is always my pattern, is the number that's in front here. That's my slope. So my slope is negative 2, which I can write as negative 2 over 1. So my slope, which is m, is negative 2. That's the other key feature from the equation that helps me actually graph the function. So I'm going to start at the point 5, 3. So 1, 2, 3, 4, 5, 1, 2, 3. That's my starting point. And now I'm going to use my slope in order to move. So since this is a negative 2 over 1, I'm going to go down 2 and to the right 1. So from this point, I'm going to go down 2 and right 1. Down 2 and right 1. Now I always fill in my graph as much as I can because I like to be as accurate as possible, which means once I get to the end here, I like to then go back to my starting point and go the opposite. So since I went down and to the right, I'm going to go up 2 and to the left 1. And I can see that this is still helping me graph some points. So I'm going to go up 2 and left 1, up 2 and left 1, and now I'm out of space. So now I can use my ruler and draw a line through all those points. Okay, question 7 is a little different. Question 7 says y equals 3 times 2 to the x. This one is not a line. This one is an exponential function, and I know that because the 2 has an exponent. So I know that this value here in front of the 2 to the power of x, that is my starting y value. Which means if I were to make a table, that 3 would be the first y value that goes in there. Because the x is by itself in the exponent, that's telling me that my first x value is 0. And then this 2 here is actually giving me my common ratio. So I have a common ratio of 2. Well, what that means is if I wanted to make more points on my table, I could just use my common ratio. So if I have a common ratio of 2, it means I'm going to multiply by 2 to get my next value. So I know that 3 times 2 is 6. And then I can multiply by 2 again to get another value. So 6 times 2 is going to give me 12. And then I can use my common ratio once more if I want, and do 12 times 2, which is going to give me 24. Now this table can help me to graph my function. So when we think about the key features of the equation that helped us graph the function, we were given a starting point, which if we look at our table is the point 0, 3. And then we were also given a common ratio of 2. Those two things together helped us make this table so that we could actually plot some points. So let's do that. 0, 3, so 1, 2, 3. And then we've got 1, 6. And then, 2, 12. Well, that's going to go up off the graph. So 2, 12 would be somewhere like up here. So we really can't graph it, unfortunately. We could, if we want, plug in some negative x values and get some other points. But really what we need you guys to be able to do is just understand that it's going to go off the graph there, and we're going to connect the dots and bring it down like this. That wasn't the best curve I've ever drawn in my life. Sorry about that. But you get the general idea. The one on your test will have a better scale here for your graph. We'll have a better coordinate plane for you to be able to actually graph the points that you created there. All right, 2 more questions to talk through. Both of these questions are in, they are both lines. There's no exponents going on. So we know we're going to get a starting point and a slope. When we look at this equation here, we can see that this is in slope-intercept form, which really just is a fancy way of telling us that our starting point is going to have an x value of 0. So since this is our mx plus b, anytime we're given the b value, it just means that the x is 0 and the starting y value is whatever that value is, which in this case is 4. So we're given a starting point of 0, 4. So I'm actually going to plot that. 1, 2, 3, 4. So that's right here. And we're given a slope of 2 over 3. Since it's a positive 2 and a positive 3, I'm going to move in positive directions. So I'm going to go up 2 and to the right 3. And then I'm going to do it again. Up 2 and to the right 3. Up 2 and to the right 3. And then remember, I like to fill in as much as I can, so I'm going to go the other way as well. I'm going to go back to my starting point, and instead of going up and right, I'm going to go down 2 and left 3. Down 2 and left 3. And then one more, down 2 and left 3. Now I can use my ruler to fill in my points. To connect the points, excuse me. So if we think about what key features from the equation helped us graph this line, we had a starting point of 0, 4, and we had a slope, which is our m value, of 2 over 3. All right, let's take a look. Last one at number 9. We've got 5 minus 4 over 3x. So this actually looks more like some of the equations that we wrote back in Module 1. We know that this number here in front of the x is our pattern, which right now we're actually calling our slope. So m is negative 4 over 3. And we know that this 5 is telling us the starting y value. So if we were to make a table, the starting y value would be 5. And we just need to think about what the starting x value would be. Since the negative 4/3 is just multiplied by x, we know that this 5 must be our y-intercept, which means the starting x value is 0. The table starts at 0 since the x is all alone. So let's go ahead and plot that point. 1, 2, 3, 4, 5. and we're going to use our slope of negative 4 over 3. So negative 4 tells me I'm going to go down 4, and positive 3 tells me I'm going to go to the right 3. So down 1, 2, 3, 4, and right 1, 2, 3. And then I'm going to do that again. 1, 2, 3, 4 down, 1, 2, 3 to the right, 1, 2, 3, 4, 1, 2, 3. And then I think I can go 1 the other way, so I'm going to go up 4, 1, 2, 3, 4, and then to the left 3, which is right there. And I can use my ruler to draw my line. So if we think about the key features that helped us graph that, well, we've got our slope, which is our m value. That was negative 4 over 3. And then we had a starting point, which was 0, 5. All right, hopefully that helps get you through the questions from your quiz and helps you prepare a little bit better for your Module 2 test that is coming up. Please make sure you ask questions of your Math 1 teacher if you have them, and make sure you do your review packet. Thanks for watching.